This is a Psion Organiser 2. This is a Psion Organiser 2. It's an organiser made by Psion that came out in the 80s, and it is the second version of Organiser in this form factor. There was an Organiser 1, which was called the Organiser at the time, which is very similar. It's different colour, it's black instead of grey, and there's a few differences in the way it operates. I haven't got one of those, but I've got a few of these, and they're pretty sturdy. Most of them, I think all of them apart from one that I've bought actually worked, and the only fault with that was one of the pins of one of the ICs inside had actually come away from the board and had desoldered. Once I soldered that together, it was fine. It's got a 2-line LCD display, and you run apps, I suppose, from various selections in menus. So you can run a calculator. You go there, move your cursor to calc, press enter, and you can type things in like 1 times 2 is 2. And then you come back out and go through the menus. The menus are also capable of having menus within menus, and this is the programming menu. It's got a built-in programming language called OPL, which these days is fairly unusual. A lot of organisers these days are simply data collection, but you can actually write programs on this device. I did do that in the past a few times. It's got a little bit of storage, onboard storage, which is battery backed up, but you had the option of plugging in these datapaks, and they just plug in the back. There's 2 slots, one there and one there, and they're basically for storage, and the expandability is quite large on this device. There's another slot here on the top with an integral cover, which is mainly for hardware, so you can plug RS-232 adapter or a parallel port adapter for a printer, or a barcode reader in that top slot. The datapaks themselves were basically the first ones that I was aware of were EPROMs. They're EPROMs on a small PCB which plugs in with a refreshingly simple 0.1 inch 2-row by 8-pin connector instead of some strange high density connector that you can't find. It's quite easy to make that connector or buy something that is equivalent. And what happened was that the organiser is actually an EPROM programmer. It's capable of programming blank EPROMs and storing data on EPROMs, and they're pretty robust. No battery needed. Programming's a little bit slow, but reading is pretty fast, and yeah, the capacities are quite high. This one's 128k. There's 8k, 16k, 32k, and so on. There's quite a few sizes. I think they went up to 256k, but that's quite a lot of storage on a device. I mean, the Hitachi 6303 that runs this has only got 64k memory map, so it's a standard 8-bit sort of microcontroller, microprocessor. So being able to plug you could plug two 256k packs in here and a 512k of storage, which, you know, in the mid 80s was a fair amount of storage, especially in a handheld device. Later on, RAM packs came out. So this is I think it's a 32k RAM pack. There was a battery there, but I took it off to preempt the leakage, and obviously this is faster to write because it's RAM and not an EPROM. Downside is it's volatile, so you need the onboard battery, but other than that, very similar to the EPROM version. They also did them in different colours. I've got a yellow and a red one somewhere as well, and there did seem to be a third-party one. I got these third-party EPROM based data packs. Now obviously if you want to erase an EPROM, you need an EPROM eraser, so the Psion way of doing this was to use one of these, Psion datapak formatter, you put your pack or the PCB in here and switch it on, and UV light will erase the EEPROM. That is why the packs are so easy to get apart. There isn't actually a screw there, it's all clipped together, and they pop apart pretty easily. They don't fall apart when you don't want them to. It's all very well designed, really. Now, the interface to this, there's only 16 pins, and you can have these high capacity EEPROMs. So what has happened, to keep the pin count down, there's an 8-bit data bus, so half of these pins are dedicated to data. But the address, now that's done by these chips here, which are counters, and those counters are used to create the address line to whatever storage device is on here, and that's the same roughly for all of the devices in the data pack. So RAM and EEPROM and flash. There are flash data packs which don't require formatting, obviously not in a UV light. You don't erase them in ultraviolet light, you actually erase them using a flash erase algorithm. But even those have counters for the address lines, and to control those counters, the other 8 lines, well 6 lines because there's power on 2 of those pins, the other lines are used to clock and reset and do various other things to the counters and the other circuitry that is on board the data pack to get the correct address for the data that you want to read presented to the device. So the interface is sort of simple in one way. Data's just 8-bit parallel, bidirectional, and then you've got these other control lines that control the address, and that sort of adds a degree of complexity to the interface. There is documentation, there are technical documents for this. There aren't any original Psion schematics that I can find for the data packs or the organiser, which is a bit of a shame, but there are some schematics that people have done of data packs, although as I was working on this project I did find some problems with them which made them a little bit odd to look at first. So it's okay working with these data packs, but it would be nice to have a way of getting the data on and off the organiser to a PC so that you can write programs off board rather than on this alphabetically organised keyboard. It's okay and you can do it, but the screen's small and the keyboard isn't QWERTY. But also it would be nice to easily have access to all the different packs that you can get, and there's quite a lot of them. There are images online, but it involves programming a data pack somehow. So I thought it would be nice to see if I could create something, a gadget that plugs into this organiser in a data pack slot, such that I could store and load stuff on SD card. So I thought about that for a little bit, and then I came up with this. So this is a PCB which plugs into the data pack. Now it's supposed to plug in like this, but my first attempt unfortunately meant that it's got to plug in like that. I wired it up wrong, and obviously it's a bit tricky using something where you've got your keys and display on that side and your organiser that side. So I basically ditched that. That's version 1. There's nothing really wrong with it. There is a few bodge wires for the OLED display. I got the supply the wrong way round again. It's something I do quite often. So I moved on to version 2. And version 2 does plug in, does work, and everything was fine. The circuit was fine, but unfortunately, because I'd chosen to use the Raspberry Pi Pico, and that is a 3.3 volt device. The organiser's 5 volts, you need level shifters, and I put some level shifters here, and you can see I've taken them off this board because they didn't work. So I was using the YE08 level shifters, and for some reason, and I'm pretty sure it's due to the output impedance of the lines coming from the organiser, I just didn't get any signals going through those level shifters, so I ditched that in the end and went for some different level shifters. So the processor that I'm using is the Raspberry Pi Pico. The reason for that is that you can buy them. At the moment there's chip supply problems with STM32 type, these blue pill type chips, so you can buy them, but also it's a much more powerful processor than the STM32 F103 on the blue pill. There's more RAM on there for a start. Instead of 20k there's 200k, which means I can store a datapak image in RAM, whereas I wouldn't be able to do a very large one, at least on the STM. So going for the Pico, needed the level shifters, they didn't work, so ditched that. That's version 2, and came up with version 3. So version 3 is here. I've got different level shifters. I'm using the 74 LVC 245, which is sort of not really a level shifter. It's a device that can have 5 volts presented on its inputs, but it's basically a 3.3 volt device, so that works quite well. I'm powering it from the Pico's 3.3 volts, but I can present the 5 volts on there, and the 3.3 is enough to drive the organiser's logic level 1. So that works quite well. And yes, it does work. So this PCB does actually function. I've got a adapter here, and that's basically so I can plug in a logic analyzer to analyse what's going on the bus. I also made a extender card which plugs into the organiser and lets me plug in a logic analyzer and a data pack. So what I can do with this is I can monitor what's going on with my board. What I can do with this is I can actually sniff the traffic going over the bus to a real data pack, and that gives me a reference and shows me what should happen rather than what is happening with my code. And the reason I had to do that is because the control signals on the datapak interface have been sort of overloaded so much. There's a lot going on. There's more than just clocking a counter for the address lines. There's actually 2 counters on some packs. Some packs have 3 counters. So you've got linearly addressed packs, which are just 1 counter. Then you've got paged packs, which are 2 counters, the lower address lines, and then the page counter, which is the upper 8 bits. Then you've got paged and segmented packs, where you've got another counter for the larger devices. So yeah, the interface was overloaded quite a lot, so it's pretty complicated, and I had to use logic analyzers to look and see what's going on and where my code was not interacting correctly. And the other difficulty was that the interface runs with clock pulses around the sort of microsecond period. The actual speed of them depends on what the code's doing, because they're totally generated by the 6303. And with microsecond pulses, I found that just running interrupts wasn't really fast enough. There was a latency of tens of microseconds for some reason on my interrupt handler, which I was measuring on the scope. So I moved away from running the interface using interrupts to using polling loops, and that turned out to be just fast enough, I think, with 1 polling loop. But what you can do on the Raspberry Pi Pico, you can use 2 cores. So I've got 2 polling loops running on this interface. One's dealing with the addresses and the other one's dealing with the sort of other stuff, the presenting of data, the writing and the reading and the segmenting and stuff like that. So running with 2 loops like that on 2 cores, that is fast enough to handle this interface that's running at approximately a megabit a second. So it's not continuous as bursts of data. The other thing that's a little bit of a shame is that the power supply is switched only when the Psion Organiser is reading or writing or interacting with the pack, does it power it up? Which means this gadget would only be powered up when the organiser wanted it to, and it's tricky for it to boot up in enough time to boot up, be ready for the organiser. Because essentially the organiser is just accessing a hardware storage device. There's no pacing on the interface at all. It assumes that the device on the other end is so fast that it can fire signals at it and get the data back basically as fast as the 6303 can operate, which with a RAM chip or an EEPROM is true. With a device like this, not necessarily true. It's only true if your code can keep up, and it looks like it can, because this works. So yeah, the power for this is USB, so you power the gadget by USB. This is my Pico Probe programmer PCB I've got, so this is a programming link running from another Pico. This is running as a Pico Probe, so that has to be powered as well. So at the moment you need 2 USB power connections, but only one needed for the gadget itself. The other problem with the fact that you need to be very fast servicing that interface is that the display and menu can't operate while that's going on. You don't have enough spare time, so the menu and so on has to be accessed with a button later on, but at the moment the code isn't really finished. I don't have the menus working properly. Okay, so I've got the organiser here, and when you turn it on, that's just turning it on. Makes sense. The second press goes out and scans all the slots, and it does things like checking how big the packs are, if they're storage packs, and also you can load ROM from devices. So for instance the comms link, the RS-232 adapter, has a ROM in it, and that loads code into the memory of the organiser, and you end up with a different additional menu item. So if we then press I, which is for info, that then shows you that pack A, the internal RAM, has 1% used. There's free 90% overall, and the diary is using 1%. I don't know why the diary is so special that it gets its own entry, but it does. So if we turn it off, plug what is a 32K RAM pack with no battery in here, so that will have no data on it, and it won't even be formatted. It will just be rubbish, random values or all zeros or something. Turn it on, nothing happens, but you press on again and do the scan, and now it's sizing the pack. So what that's doing is the equivalent of putting the EEPROM type pack into the ultraviolet eraser, and it's writing FF to all the unused space. And it also writes a header at the beginning, which indicates to the organiser that this is a formatted data pack. So if you press on again, it goes out and quickly sees that header and doesn't bother sizing the pack. So now if we press I, you've got pack A, 1%, that's the internal memory. Pack B, 1%, that's the RAM pack that is plugged in and sized. So what I'm going to do now is get all the cables together and plug the gadget in. Okay, so I've got power to the Pico that's running the gadget and to my Pico probe, so I can program this over this link. If I turn it on there, so that's just on, then we scan, nothing happens. Now the reason for that is that this Pico is currently emulating a 32K ROM package, so EEPROM package, or pack, and it's the phishing pack. So if we go and press I, you've got pack A, 1%, yeah, pack B, that's the RAM pack. Now you've got pack C, which is the gadget, 28%. So 28% of the 32K RAM pack, sorry, EEPROM pack has got stuff in it. Now if you go and have a look, you can press find, and then you can move to pack C and hit enter, and you'll find what's on it. Now it's saying end of pack because there's no data records on there. Find finds data records. Now on this pack, the phishing pack, it's actually programs. So if we go to the prog menu and we do a dir, which is directory of pack C, and hit enter, you've now got the OPL programs or procedures that are on there. and there's quite a few of them. Now I don't know what they do. I haven't looked at the instruction manual for this. I'm not even sure it's available, but I'm just using it to check that the operation is fine, and that is what you would expect. So that is now emulating a 32K. Well, it's actually emulating a 32K EEPROM, even though I've allowed the buffer that is stored in the Gadget to be writable. But that's just me fiddling around with headers and so on to get this to work. So what I'll do is I'll download code to this to make it emulate a 32K RAM pack rather than an EEPROM, and then we can store some stuff on it, some random data records. So it'll download and the display will reset. A few seconds. There we go. So now, I mean, it's been plugged in all the time. Now it's emulating a 32K RAM pack. So if we turn this on, that's just turning it on. Scan the packs, and it should have found. There we go. I had to press it twice for some reason. It was sizing it, so it found that wasn't a valid pack. Went out and reformatted it. I don't know why it had to do it on the second press there. I'm not really sure what this does internally, because there's no internal listings of the code and so on that I can refer to. So now, if we go to I, pack A 1%, pack B 1%, pack C is now 1%, because this is a RAM pack. It's just been sized, it's blank, you've got 32K to store stuff. If we go to find on C, nothing there as before. If we go to prog and dir on C, nothing there because it's a blank RAM pack. It's not got a preloaded pack plugged in, if you like. So now what we can do is we can save on pack C something called GHI, and we can put some data there. So that's now been stored in pack C. So if we do I, pack A 1%, pack B 1%, pack C 1%, because it wasn't big enough to actually up the amount of used percentage. So now if we do a find on C, and just hitting enter means that it sort of find everything. You can search for various strings there if you want, and find a particular record. There you go, GHI data, hit enter, end of pack, nothing else there. So that is now stored in the RAM buffer of the Gadget, and the idea when the code's finished is that you'll be able to exit the sort of pack emulation mode by hitting a button, which does work, and then store and load buffers and images to and from the Pico buffer and SD card, which means I could store that data onto SD card, give it a name or whatever, and then recall it at any time. So you've got sort of the number of 32K RAM packs as you are available to fit within whatever size SD card you've got, which is going to be quite a lot. Unfortunately the menu's not working anymore, so now there's no pack there because the polling loop that is handling the interface has exited, and it's now in the menu loop. So it's now trying to size pack D. I have no idea why it's sizing pack D. I've seen that before. I think it's because I probably haven't left the lines in a good state or something. But if we press info, it's now locked up, and that's because the code to actually handle the interface has done something which causes the organiser to sit in a loop. I'm not sure what that is. It's a bit strange. So if I stop it on Eclipse and then just rerun that code, that will restart the interface, and you'll see the cursor appear once the code's loaded. Now I'm surprised this has happened because it's just a RAM chip. It doesn't actually do any polling, and it's back again. Pack A and B. So it hasn't recognised pack C because we haven't come out and done the scan, like so. Now it's sizing it, and now it will be back as pack C. Obviously, there you go, 1%. Obviously if we do a find now on pack C, nothing there because I've wiped out what we stored before. So it's working. It can present preloaded EEPROM packs. I have to fiddle with the header a bit. I'm not sure why it doesn't completely emulate EPROMs. Something with my code means it doesn't actually emulate EPROMs unless I fiddle with the header a bit, but I can probably sort that out. And it can be a RAM pack. That works quite well because the organiser formats it. There's no problem with headers or anything because it's writing its own header. So RAM packs could be saved and loaded, and other packs could be saved and loaded from the SD card. Only thing I do need to do is sort out this menu problem. So the idea is that you use the gadget just as a pack, and then when the organiser is either off or you know it's not accessing the data pack, you flip into the menu, do whatever you want to do, save it, and go back into the emulation of a pack mode and carry on. So you can back up whatever data you got in a RAM pack to SD card, or you could load a completely different pack and then plug it in. So it's looks like it might be quite useful.